In this lesson, we'll take a look at the product and quotient laws for logarithms and how to use them to expand expressions, simplify expressions, and evaluate expressions involving logarithms. And on the first page, I'm just going to show you what those two laws are. The product law says that if you have the logarithm base a, and it doesn't really matter what base a is as long as these bases are the same, of a product pq, then you can rewrite that as the logarithm of p base a plus the logarithm of q base a, again the same base. So the logarithm of any product can be written as the sum of the logarithms of all the parts of that product, the two parts p and q. Now we normally use the law in this direction. We take a sum and simplify into one logarithm, although you can use it in either direction however you need to use it. One example of this product law, if we had the logarithm of 5 base 3 and the logarithm of 8 base 3, now notice the bases are the same, and we're adding those two, then we could rewrite this, and again we're going in this direction from the sum to the product. We can rewrite that as the logarithm base 3 of 40. Notice that 40 is equal to 8 times 5. So I could rewrite this sum of two logarithms as one single logarithm using that product law. And if I wanted to decompose the log of 40 down into two logs that are added to it, I could write as the log of 5 plus the log of 8, of course both base 3. Just to demonstrate to you that this does work, if I were to take my graphing calculator, or any calculator, and find the log of 5 base 3, so it's the log of 5 divided by the log of 3, it's 1.4649, etc. And the log of 8 base 3, it's this number. And the log of 40, notice that I'm saying here that this logarithm plus this logarithm equals this logarithm, so this number right here plus this number right here should add to this number, and you could go right through the decimals you wanted. 2 and 6 add to 8, 5 and 2 add to 7, 3 and 9 add to 12, carry the 1, etc., right down to the end, and you'd notice that this number plus this number would equal the log of 40 base 3. So that's just an example that that is true. The quotient law says if you have the logarithm of p over q, I'll call it base a, it's equal to the log of the difference between the two logarithms. So the log of the numerator minus the log of the denominator, log of p minus the log of q. So for example, if we had the log of 80 base 2 minus the log of 5 base 2, we could rewrite that as one single logarithm as the logarithm, same base, still base 2, of 80 over 5. And so again, I'm going in this direction. I'm taking the difference of two logarithms and writing as one single logarithm like this. Now of course 80 divided by 5 is 16. So this is an example here now of how we could actually simplify the difference of two logarithms quite a bit. And so 16 actually can be written as 2 to the 4th. The nice thing about that is the base of the logarithm is 2. So the logarithm of 2 to the 4th base 2, again, if that base of the logarithm is the same as the base of the power, remember that equals the exponent. And so that should equal 4. Now, a lot of people don't have to go through this step here. This logarithm means what power do you raise 2 to get 16? Of course, the answer is 4. 2 to the 4th is 16, so that's another reason why that equals 4. I could demonstrate this using my graphing calculator as well. If I took the log of 80 base 2 and the log of 5 base 2 and subtract them, I should get 4. That's what this is saying here. And of course, notice if you do take this number, and notice the decimal part's exactly the same, so this decimal minus this decimal will be nothing, and so 6 minus 2, of course, is 4. In this example, we're going to use those laws, and of course also the power law as well, to express this sum and difference of logarithms as one single logarithm. And that's one of the things that those laws are used a lot for, and that's really just simplifying things, write it in a simplest form. And so in the first example here, we have the log of 100, and they're all base 5, minus the log of 10, plus the log of 3, of course all base 5. And so the log of 100 minus the log of 10, so the quotient law from the last page says we would take the 100 and divide it by the 10, so we have 100 over 10, and then we're adding to that the log of 3. So since we're adding that logarithm to this, we would multiply by 3. Again, these two are added, so it's 100 times 3, and of course minus the log of 10, so the 10 is divided into that 100 times 3. And of course, 10 goes into 100 10 times, and then 10 times 3, of course, is 30. So we could rewrite that then as one single logarithm, as it's the log of 30 base 5. Now in example B here, we're going to use the power law, and we'll bring that 2 up and write it as an exponent of the x. Same with the half, and write it as exponent of the y to the fourth. And the same with this 3 here, and bring it up and write it as an exponent or a power of 2 to the x. And so then it would look like this. The x would be squared when we brought that 2 up. We would have y to the fourth raised to the power of a half. And the 3 comes up as it's the power, the third power of 2 to the x. And now, so what I'm going to do is I'm going to simplify this and this before I start combining them into one single logarithm. Remember, when you have a power, you multiply the exponent, so half times 4 is of course 2. 2 raised to the power of 3 is 8, and of course x cubed is x cubed. So now I want to write this as one single logarithm. So these two logarithms are added, so we would go the log of x squared times y squared. And since we're subtracting this logarithm according to the quotient law, we would divide that by 8x cubed. Now we can simplify this. We have an x squared in the numerator and an x cubed in the denominator. So that x squared will divide out of into the x cubed, leaving just an x. Notice the way I often do that when there's just an x left, I cross it off completely, and I'm crossing off the exponent, showing that there's just a single x left. X cubed divided by x squared is just x. And so our final answer would be the log of y squared over just 8x in the denominator. In example 2 here, asked to evaluate using the laws of logarithms. And so first thing I'm going to do is rewrite this as one single logarithm. It's the sum of two logarithms, so according to that product law, I could write that as the log base 8 of 2 times 32. Of course, 2 times 32 is 64. Now, the answer to that logarithm means what power do you raise 8 to get 64? And of course, some people can look at that right away and say, oh, I know that 8 squared is 64, so the answer should be 2. The other thing you can do is you can write the 64 as a power of 8, it's 8 squared, and then realize that's actually another property of logarithms. As long as the base is the logarithm and the base of that power are the same, it equals the exponent. So that's another reason it equals to 2. Now in B, I'm going to use the power law and bring that 2 up and raise the 5 to the power of 2. So this would be the log base 25 of 5 squared, and of course 5 squared is 25. Now the answer to this logarithm means what power do you raise the 25 to give you 25? And of course the answer to that is 1, because 25 to the first power is equal to 25. So the answer would be 1 here. For C, remember, my base is 6, so I would really want to write this as a power of 6, again, to use that rule. And so that's why I'm writing the 36 as 6 squared. And then the fourth root means the power of a quarter. Now a power of a power, you multiply the exponents, so 2 times a quarter is a half, or 2 quarters, which reduces to a half. So again, if the base of the logarithm and the base of this power are the same, then that should equal the exponent, so it equals 1/2. In D, I have the log of 24 base 4. Notice they're all base 4. This logarithm and this logarithm are added, so I'm going to write as one single logarithm, multiply the 24 by the 64 thirds, and this logarithm is subtracted, so I'll take that quantity and then divide it by 32. So this is what it looks like. Again, don't forget to write the log base 4 here. 24 times 64 thirds, because these logarithms are added, so I've multiplied the 24 by 64 thirds using that product law. And then the quotient means I'm dividing by the 32, because that one's subtracted. Now, 3 goes into 24 8 times, so I'm left with 8 times 64 over 32. And of course, we can just multiply and divide those numbers out. 8 times 64 divided by 32 is 16. So we have the log base 4 of 16. And of course, the answer to that means what power do you raise 4 to give you 16? And of course, the answer to that is 2. You could also rewrite the 16 as 4 squared. And so again, base here are the same, so it should equal that exponent.